Hello! Welcome to Squid Essays. Inking your academic pen. My name is Julie and I will be your instructor as we read through continuous casting lubrication. The article source is embedded in the video description below. Feel free to read along. Please note that you can get a custom, plagiarism-free essay for as little as $10 a page at Squid Essays. The link is in the description. The steelmaking industry is one that is comprised of very large equipment that can operate at very high temperatures, both of which use lubrication to prevent damage and improve ease of use. Lubrication is also used in continuous casting to prevent the steel strand from sticking to the mold. For these reasons, lubrication is a necessary component of a properly functioning steel mill. Each type of lubrication will be discussed individually as they are both very different. Friction is a force that is seen everywhere as it is what holds most objects in place. Physics defines friction force as the force exerted on an object by a surface acting parallel to the surface, in the direction that opposes sliding. 1. This means that all surfaces that slide across each other will experience friction. If the surfaces are not moving relative to each other, then the surfaces are experiencing static friction. If the surfaces are moving relative to each other, then they are experiencing kinetic friction. Both static friction and kinetic friction are defined using constants known as coefficients of friction. A more slippery surface will have a lower coefficient of friction, therefore a lower friction force. Objects that are sitting still, such as a box on the floor, are experiencing static friction with the surface they are sitting on. To move them parallel to the surface of interaction, as with the box on the floor, the force of friction must first be overcome. With objects that are in motion, kinetic friction is a force that is constantly applied to the moving surface that will force the moving object to slow down unless the force moving the object is greater. The mass of an object also has a significant influence on friction. A larger mass will have a greater friction force. Lubrication is used to decrease the coefficients of friction in both static and kinetic friction. Component lubrication. In metal joint components, there is often a point where the friction in the joint will cause its failure. This friction can cause the formation of heat within the component, which can additionally cause swelling and seizing of the part. Friction can additionally cause abrasive and adhesive wear within the component, which could shorten the lifespan of the part by wearing the material away. This type of lubrication will be referred to as component lubrication. Component lubrication can be found almost everywhere since there are numerous moving parts in a steel mill. In continuous casting there are still numerous moving parts, but the most important moving parts are the caster mold and the support rollers. Not only are these subjected to the weight of the steel strand, but they are also subjected to the heat coming off of the steel strand. Continuous casting lubrication. Beyond the numerous forms of component lubrication, there is also lubrication that takes place in the mold of the continuous caster. This lubrication serves multiple purposes, the most general of which is to prevent the steel strand being produced from sticking to the mold in the continuous caster. If the strand sticks to the mold during casting, it can cause defects on the surface of the steel strand being produced, can damage the mold significantly, and can even cause breakouts during casting. Lubrication in the continuous caster mold is called mold flux. Mold flux can be either a powder or oil. Mold oil was originally used for continuous casting but has been replaced by mold powder in many circumstances for many reasons. Mold oil, however, is still used by some companies in billet casting because they are open cast. Mold oil actually forms a gas layer between the strand and the mold wall, which provides a boundary layer of protection. Powder mold flux is used exclusively when a submerged entry nozzle is being used between the tone dish and mold. If a powder is used in open casting, then the stream of liquid steel flowing from the tone dish will pull the powder into the strand, causing inclusions. When this mold flux is applied to the surface of steel in the mold, it forms several layers including a solid layer, liquid layer, and a semi-solid layer. The semi-solid layer is a slush of partially liquid flux and solid flux. The liquid layer is what flows between the strand and the mold, preventing the strand from sticking to the mold. Powder mold flux and steel strand interaction in the continuous casting mold. As the steel strand outer surface solidifies into the shell, the strand will actually contract, allowing for a layer of liquid to flow between the strand and the mold. This liquid layer is what lubricates the strand in the mold. This image was taken from an article which was written by Mills and Fox. 2. As the molten steel comes into contact with the water-cooled copper mold, the contacting surface of steel solidifies into what is called the shell. The forming of the shell is a key component in continuous casting. When the shell is formed, it contracts away from the mold, allowing for penetration of the liquid mold flux between the strand and the mold. This penetration of liquid mold flux between the mold and strand is what provides lubrication to ensure that the strand does not stick to the mold. The motion of the caster mold is also a critical aspect of continuous casting, which would not exist without it. The mold will oscillate up and down at a speed that is faster than the speed of the strand. As the steel strand is moving downward through the mold, it is actually moving faster than the strand is, preventing the strand from sticking to it. This is called negative strip. After the downstroke and negative strip, the mold will then move up, causing positive strip. This continuous application of negative and positive strip can prevent some sticking of the mold to the strand, but lubrication through mold flux definitely helps. The benefit of powder mold flux versus oil mold flux can also be shown in Figure 2, which is a graph of the friction recorded during casting time. This graph was taken from a presentation given by Dr. Kent Peasley. 3. The graph in Figure 2 shows several things, including but not limited to casting powder having a lower friction index than oil, and casting powder having a more consistent friction index over an extended period of time, unlike oil. Casting powder shows a lower friction index than that of oil, and also shows a more consistent friction index over a large period of time, unlike oil. Types of mold flux. There are many types of mold flux produced, because each mold flux used has a composition that depends on the chemistry of the steel being produced. Fiseco Steel has provided a table, shown as Table 1, which shows the typical composition ranges of powder mold fluxes. 4. Notice that a significant portion of a mold flux, ranging from 45 to 95%, is CaO and CO2. Both CaO and CO2 are significant factors of slags used in the furnace when melting the steel. Other mold flux components such as carbon can be adjusted to match the chemistry of the strand being produced, so as to not decarburize or carburize the surface of the strand. Also, additions such as fluorine can be added to modify other properties such as a melting temperature and fluidity. There are several generic types of mold flux available, including fly ash powders, synthetic powders, prefused or fritted fluxes, and granular fluxes. Fly ash powders are powders that contain a significant amount of fly ash. Synthetic powders are blends of fine powdered raw materials. Pre-used or fritted fluxes contain significant portions that have been pre-melted and sized. Granular fluxes are spherical or extruded sections which are designed to have a lower amount of dust than other fluxes. The form of powder purchased depends on the preferences of the customer. Additional benefits of mold flux. Mold flux is not only meant as a lubricant for continuous casting, it also provides other benefits to continuous casting, including thermal insulation, atmospheric protection, absorbs inclusions, and improves thermal conductivity in the mold. 5. The layers of different states of the mold flux, solid, liquid, semi-solid, slush, that are on top of the liquid metal in the mold will serve as a barrier between the strand and the atmosphere. This will prevent the absorption of oxygen and nitrogen, and serve as a thermal barrier to prevent the top surface of the strand from solidifying. Since the mold flux will form a liquid layer on top of the strand, this liquid layer will act as a pseudo-slag layer. This slag layer will absorb further impurities left in the liquid steel such as Al2O3. Conclusion: mold flux is a necessary addition to continuous casting that serves multiple purposes beyond that of lubrication. However, without the lubrication provided by mold flux, there would be no continuous casting. The composition of the mold flux depends on the chemistry of the strand being produced, and the form of powder sent is dependent upon the wishes of each customer. References: 1 Young, Hugh D. Sears and Zimanski's University Physics. 12th ed. Volume 1. San Francisco, Pearson Addison Wesley, 2008. Print. 2 Mills, Kenneth Z., and Alastair B. Fox. The role of mold fluxes in continuous casting, so simple yet so complex. ISIJ International 43.10, 2003, 1479-486. Print. 3 Peasley, Dr. Kent. Continuous Casting Steel. Lecture. 4 Moore, Albert J., R. J. Phillips, and T. R. Gibbs. An overview for the requirements of continuous casting mold fluxes. Web. 5. Mold flux. Lecture R. T. Vanderbilt. Web. www.rickvanderbilt.com/vand_mf.ppt. Thank you for taking your time to listen to me. I hope you enjoyed learning about continuous casting lubrication as much as I did. Kindly remember that you can get a custom, plagiarism-free essay at Squid Essays for as little as $10. The link is in the description. See you next time.